Good morning, everyone. First, let me introduce ourselves. Judit Rauscher, she was responsible at this case study or design work for evacuation simulations. My colleague Csaba Szikra, who was responsible for fire modeling, and I'm Lajos Takács. I was involved in both traditional fire safety design and fire simulations. So, we'll introduce this arena or sport event hall called MVM Dome, which was finished in 2021 in Budapest for the 2021-22 Handball European Championship. And this is a multifunctional building, and the design was started in 2019. And as I mentioned before, the building was finished by 2021 December, which was a pretty short time in a design and build construction. So the building has 5 floors, and the highest floor level is 23 meters above the ground. The most important data, there are 20,000 people, I mean the capacity of the spectators area, while at certain events, even 24,000 guests can be in the building. So this is one of the largest indoor area now in Europe. The total floor area is more than 50,000 square meters. It is divided into 17 fire compartments. There is a fire detection system and sprinkler system, and the public address system. All the staircases are pressurized, and there is a smoke and heat ventilation system in both arena and the concourse areas. So our first problem was what to do with the extreme dimensions of the buildings, mainly the headroom or the clearance, which is at the highest point is 40 meters, exactly 40 meters, and such a large building must be protected with sprinklers with sprinkler system in Hungary. So obviously, activation of the sprinkler and the so-called skipping hazard is a challenge. And interestingly, the European sprinkler standard says only one sentence about buildings exceeding 12 meters. Authorities shall be consulted at these buildings. Okay, we have consulted with the authorities, they required sprinkler. Then we can finish this presentation, of course, but obviously we checked what to do, what kind of sprinklers can be used. And we have a guideline in Hungary about sprinkler systems or fixed firefighting systems, and it recommends quick response type of sprinklers at such a high clearances, and it refers to full-scale fire tests. So you can see here the oh, I'm sorry, wrong direction. Finally, our sprinkler designer colleague offered a special quick response extra large orifice sprinkler according to a publication about large headroom sprinkler tests, full-scale fire tests, with a K factor of 160 and an activation temperature of 68 degrees and an RTI factor as low as 28. So our goal was to test the large area, whether the sprinkler, how the sprinklers are activated, what kind of fires can happen over there, and what are the activation sequences, and whether there are skipping problems or no. So fire modeling is usually provided with predetermined fire scenarios and fire sources with simple cubes, but we felt here in this situation more complex or more complicated objects are required for the good or a proper or more realistic fire modeling. Just 2 examples which were used by us at other fire modeling tasks, forklift and lorry fire source where the fire, where there is a hood over the fire, a horizontal metal plate representing this type of vehicles, usually have metal roof. So here we used three type of fires. The first was a very small, relatively small fire at the spectators area, which has a peak heat release rate of 1.8 megawatt from SFPA head boom, but it was not able to activate or actuate the sprinklers, obviously. We have stage in at certain events, and obviously over there 5, 10, 20 or 30 megawatt fires can be expected, but anyway, it is not obvious we can model such a fire with a small cube. So we have tested not only with a simplified method, but with a complex form shown below, which represents a stage scenery with a spreading type of fire. So here we have our results. The activation times were pretty long, obviously, because of the high clearance. But over 10 megawatt fire source, at least 1, 2, or even more sprinklers were activated. Obviously, increasing the fire source heat release rate, more and more sprinklers were activated. And obviously, it was even more interesting at spreading type of fire, where the activation times were a bit longer. And interestingly, here we had a important conclusion. The smoke and heat ventilation and the fresher supply must be delayed till the last sprinkler activation in order not to have skipping or to minimize skipping effect, because otherwise, if the smoke and heat ventilation is activated automatically and without delay, the plume was not vertical, and then obviously at such a high clearance, not the sprinkler, so the sprinklers were activated in another position. So obviously we still had at the end some sprinkler skipping problem. Here there is a layout showing all the activated sprinklers at one of our fire scenario, showing that of course several sprinklers has been activated. So the fire is more or less covered with activated sprinklers, but anyway, a complex approach is needed to provide proper results, because not only the sprinkler activation is important, but obviously if we have a delay, a long time delay at the activation of the smoke and heat ventilation, then it means some kind of safety problem for the evacuation time, which will be shown by Judit. Anyway, we have two tasks. First, to provide a proper condition for evacuation. Second, to provide proper condition for firefighting intervention. And for the second task, we have to calculate precisely the total emergency response time of the first fire brigade, according to our fire modeling guideline, which is shown here. And then you can see here the test slice 2 meters higher than the floor, showing the results of a stage fire, of the previously shown stage fire, shown not only the visibility, but the possibilities of the firefighting intervention directions. According to the Hungarian guideline, the visibility can be less than 5 meters only within a 25-meter radius circle around the fire source, which was fulfilled by the controls and the building, even without this type of long delay, of course, because of the enormous hall or room or area in a hall. So this was the story of the event hall. And the other challenging task was to provide proper conditions for evacuation at the concourse areas. Here the ground floor is shown. Only one part of the ground floor was part of the concourse area, but here you can see the first concourse level where we provided not a simple smoke and heat ventilation, but a smoke control system. We divided the concourse area into 6 or 8 zones, depending on the level, and there were multiple reversible smoke and heat ventilation and air supply, mechanical air supply points, and they were controlled according to the position where the fire broke out. So in the affected zone, virtual zone, because there were no real draft curtains or smoke barriers, at the affected fire zone or a smoke zone or a virtual compartment, the smoke and heat ventilation was activated, and in the neighboring zones, air supply was activated. You can see here we used different points, and you can see here just one of the control scheme showing the affected zone with red and the heat and smoke ventilation, and the air supply zones, neighboring zones, with blue color. So finally, we were able to provide proper conditions for the evacuation. You can see here one of our results showing that the smoke spread is quite limited, but a very important consequence was that it is working only with small or medium scale fires. So fires over 1 megawatt power output or heat release rate would be too much. So there were two additional requirements. Only small amount of combustible materials can be placed in the concourse area, and obviously there are large special places where the amount of combustible materials are more, like the buffet. Buffets were separated with automatic or active type of fire curtains from the concourse area in case of fire, and with this type of solutions the conditions were acceptable. So it's your turn.
It's okay. Hello, then let's speak a bit about evacuation. First of all, I would like to say some words about Hungarian regulation. As you know, scenario is defined by the following characteristics. For example, the layout, the agents, numbers and characteristics and so on. But Hungarian legislation says for a design process, we only have to check the worst case scenario. But we believe that it is not enough for such a building. So we try to check more and more layouts and scenarios in this case. Due Hungarian legislation, there are 3 options to verify the Egress process by observing geometric parameters, by calculation, or by evacuation simulations. Due the codes, for this special building, there would be a 90 seconds period for the movement, for the first part of the movement, so to reach the fire-safe route, which is due the size of the building was not good for us. It's too small time. And in the code, we can use pre-movement time 0, and for calculation, this speed. We decided not to plan or not to design this building with the prescriptive code. Then we checked with evacuation simulations. So we determined the asset time by FDS simulation and the asset time by Pathfinder. Here is some pictures about the building. There are 4 external escape stairs from the first concourse level. They can use it. And from the upper side of the building, they can use 6 staircases. And there are one more route, the main stairs in the main lobby. It's an open area in the concourse areas. The investors' aim was to build a multifunctional building for any kind of events. The architects made special solutions for that. So they divided the grandstand for three areas. The lower grandstand is made usually with mobile stands. It can be pushed in 3, 8, or 11 rows, so they can change the arena. And the VIP sectors and the upper grandstand is fixed with fixed seatings. At the conceptual plan, the architects draw up about 12 layouts. It's okay. We decided to plan simultaneous and complete evacuation of the building because we found it would be the best solution, and the areas have to be planned for this number of spectators. At the permit plan, we had to choose only one layout because of our short time, which is the basic we used. This was the handball. And we made only for this the evacuation simulation, and we checked it with 6 fire scenarios. And from these 6 scenarios, we merged the results with only 3. At the construction plan, there are many other types of layouts came into the architect's mind. You can see the sports from handball to ice hockey and curling and even swimming pool. So that's a very wide range. And for events, the stage can be placed more places and have side stage. And there are other events like monster truck shows, so it's a really multifunctional plan. We try to make groups from these all layouts, which has similar features for Egress process. So we created 14 layouts, and we checked them as typicals or extremes, and we checked it with 39 fire scenarios. At the end of the building process, we had to check it again because some modifications were during construction. So we rechecked that. And after that point came the building operation manager into the design process at the end and said there would be much more layouts in this building to have checked, but this project is ended, unfortunately, so we didn't made this much more layouts yet. Here are the parameters for the evacuation simulation. You can see the agents and the pre-movement times are fixed numbers. We know this is a simplification, but this was the agreement with the authority. And we used the maximum visitor and staff numbers, and with wheelchair users and visually impaired people also. And for the merge simulation results, we checked only the minimum visibility of 15 meters above 2 meter high the floor. In the green place, you can see the typical layouts and the numbers we can check and we can prove it would be work in this building. And now some videos. You can see the central stage layout and 11 rows from the grandstand is pushed in, so it's a bigger place for standing area. And the fire results is, you can see is the surface of 15-meter visibility. And we try to check our results and to show the client and the authority also that how it would be looking with the building structures and then after without building structures. So it's a nice work. So there are 2 more videos from other perspective. I think it was very useful for the client also and for the authority also and for us also that people during the crowd they would not notice almost anything about the smoke up on the at the ceiling. So it's good news for me, I think so.
So the height of the steel girders is more than 5 meters. So the bottom level of the mother grid is 27 meters and the top is 40. So it disappears.
There is 4 videos parallel. It's the same scenario, the central stage, but after time. This is, I would like to show you and the authority also how sprinkler activation affects the smoke and the environment for egress. So after that, it was our goal to reach the evacuation ended before the sprinkler activated, because it's terrible, I think so. And it was about for this this layout about 400 seconds. So it's a huge amount of time than 90 seconds. And pardon. On our experience has shown that the building areas operate completely different in the event of fire. So we checked many places on the concourse area. These videos you can see a fire scenario made in the main lobby and the ground floor with a garbage litter. So a small fire. And you can see the people have to go through this main lobby on the main stair, but they are not affected from the fire or from the smoke and the other things. So we found it is relatively safe for them. And based on our experience, there are more ways to determine asset time using FDS. In simpler cases, we use only slices, test slices, to say the time. But like in this building, in a complex geometry, we think the better way is to merge simulation results. If we think so, then why don't we always do this way? Because it has a disadvantages also. The time factor. It's very difficult to predict how long this work makes, and it is not linear because as other planning phases, because we don't know how many mistakes are in the building and in the simulations, and how many reruns we needed during this work. So it is very long hours and very many reruns we need. And because of these parameters, it's an extensive design phase for the investors. So usually they don't want to pay it. But we think it's the most real solution or design tool in the fire safety, but only if the models is done right and professionally well. So from this case, real case, our conclusion was that it was very useful for us also to participate the whole design process and to work the whole process with simulations. And
obviously, to avoid extensive sprinkler skipping, sprinkler activation times and patterns must be checked. As a conclusion, long sprinkler activation times in large, overcrowded halls are not bad, but obviously they have to cover the fire or they have to control the fire. And what else? I agree with Judith's conclusion. These merged fire and evacuation simulations are the best, but they require longest time. So that's the reason why it was not able to finish within the building permit procedure. We have to extend this activity to the construction work phase, and in the design and build construction, it was a real challenge. So thank you very much for your attention, and I wonder if there are questions. We are free.
I would like to say one more word. Our conclusion was that there are always more and more usage layouts than the designer thinks at the beginning. So that was our work. Thanks for your attention.
Okay, so we have a couple of questions in the chat already, and then I'm assuming some from the room. So the first was, how do you estimate the size of the fire that can be expected in the handball area? And additionally, what growth rate do you expect? You can speak, you have.
So, as I tried to mention, we have numerous fire scenarios starting from 1.8 megawatts till 30 megawatts. So it is hard to estimate. So that's the reason why we have to check the behavior of the building with a totally different fire heat release rate, and even the form or the fire source can be totally different. So that's why we have had multiple scenarios.
The activation time seems to be long. Would you replace with fast response heads or sensors for the activation of the sprinklers, I think?
They were fast response type of sprinklers.
Okay.
RTI was 28, so it is quite low.
Let's see. I was looking for Eric. Are you here? Did that answer the question, or do you have more? Yeah, no, the delay is maybe beneficial. Let's see, and then with the huge volume, why do you need a mechanical air supply? And positioning it close to the fire area, it could maybe, I think, augment the turbulence. So why don't you supply air farther from the fire?
Because there were, so as maybe the image shows, there are not too many transparent surfaces, so most of the building is covered with solid panels, and it's simplified. So we had to follow the architectural design. I assume the question regarded to the concourse area, so which has a direct contact with the outdoor area, but maybe our first slide shows this properly. This one. Yes.
There are not so much place for just windows. There are not so much place for windows because of the design of the building and because of the price.
It was cheaper.
Yes.
There is a simple answer. But anyway, using smoke control systems, so obviously validating with simulations, can show the efficiency, and obviously our first results were not satisfactory, so we had to work a lot to test how to control these multiple points, for sure. We hadn't explained the whole process, because then we will stay here till night, but anyway.
Great. And then a comment that it was very interesting. During commissioning, did you use any hot smoke tests to check the performance of the smoke management system in the concourse spaces? And was the system designed to operate with multiple zones activating at the same time?
No, real smoke test was not carried out.
Okay.
It was a decision by the constructor and the authorities.
And then was the system designed to operate with multiple zones activating at the same time?
With multiple
zones, you had all of the different zones. Can they activate simultaneously?
No, they were controlled according to the fire position. So only the exhaust was operated only at the affected zone, and at the neighboring zone, the air supply was provided. So to keep the smoke as small space as possible.
Okay, thank you. And then, did you take into account the extinguishing effect of the sprinklers, or was the fire free to develop to its peak heat release rate, which remained constant until the end of the test? The comment, it's just kind of interesting with fires of like 30 megawatts or so, like how that performed.
So 30 megawatt was 30 megawatts. So at these scenarios, we haven't taken into consideration the extinguishing effect. But obviously, there are some possibility to take into consideration the cooling effect of the sprinkler now in Hungary. Of course, not to extinguish the fire, but to control the fire. But this technology was not used here, because it was released only this year in our guideline.
Okay. And let's see. Do you agree with the used pre-movement time equal to 0? And do you think that that assumption is representative of human behavior in fire?
No, in the 0 pre-movement time is in our code in Hungary. We used in these simulations after the fire alarm 30 seconds. It was a decision because in the house there are a public address system and with evacuation voice instructions through this system. So it was the agreement with the authority because of these parameters.
Okay, great. Questions in the room? Okay.
Well, please, if you can share how much time did you spend on this endeavor? And I have another thing to say is about the effectiveness of the fire sprinkler, where the focus was on the time to operate and if they will operate, but the effectiveness of the fire sprinkler, especially the penetration force from 40 meters. You said it's a control mode, so it's a small orifice, it's not a lot of water. In 30 megawatt fire or 40 meters, they will probably not penetrate the source of the fire, so it only doing damage to the smoke layer. So I think maybe more effort should go to convince the authorities to omit these sprinklers than try to show how they are not making any damage due to late activation.
So it is true, but so anyway, let me ask the first simple question. We worked all together, so there were altogether 9 fire safety engineers who were working on this project, and we are only 3 here. But anyway, a large group, and I don't know, maybe 18 computers were required for such a, but we are ready to make such a huge project right now. The second, you are right, we are not sure how the sprinklers will behave in case of a real fire. That's the reason why we had selected a lot of fire types, and anyway we worked together with the sprinkler designer, and this type of sprinkler what I showed here, this Orifix sprinkler was selected, or Curelo sprinkler was selected according to publication, which was based on a full-scale fire test with large headroom, but unfortunately not 40 meters. So there is no 40 meter clearance sprinkler test yet. But anyway, the authority required the sprinkler, so the best thing what we could do is to check out all the publications and to test as many fire scenarios as possible.
I was wondering why you use a threshold of 15 meters for the visibility.
Because according to the Hungarian guideline, it is required. It is 15. But I saw here a lot of presentations that in other countries it is 10, but in Hungary it's 15. Hungary is always different.
And with his question in mind, was it check the visibility for self-illuminated signs or reflecting signs? The visibility factor.
For reflecting, yes, you are right. Only for reflecting, because otherwise 2 simulation runs must be provided for internally illuminated and reflecting the reflecting is simpler.
Thank you.
Yeah, right.
Beautiful presentation.
Thank you.
Thank you. My question is, how do you decide the initial position of some people, like, for example, the wheelchair users, which their position will influence the evacuation a lot. For example, if they are close to the exit, they can evacuate quickly, which means they only have little influence on the whole crowd. But if they are far away from the exit, they will reduce the crowd speed during the whole process.
Yes, I know. With the architects, we could discuss for wheelchair users are dedicated places on the lower grandstand concourse level, so they are placed as near as possible to the external stairs, and at the top of the external stairs there are a bigger place for them to wait and to wait for the fire brigade to help them. And there are 2 more evacuation lifts in the building, elevators in the building also to use for them from the upper, only from the VIP level. The upper grandstand they can't use because there are no place for them for seeing the event. So they have dedicated places in the building.
Thank you.
Anyone else? No? Okay, thank you so much for your presentation.
Thank you.